So today is lesson 8 of Intro to Web Programming, and we're tackling a really important topic, which is how to enable basic authentication in a PHP MySQL web application. So we said we've got a couple of options in terms of being able to store user identities as they move around our site, because we've talked about how HTTP is stateless, and if we don't store a user's identity once they log in, we will not know who they are as soon as they go to a different page. So we've got two options. We have both a session object and a cookie object. We want to talk about how each of these work and maybe which one of them would make more sense for us to use. So you suggested cookies. So what can you tell us about using cookies, Bikramjit?
Locally as a text file, and the sessions are stored how to store them, and sessions are more secure. And as soon as we quit the browser, the session data is lost, and the cookies have an expiration date, so like we can access the website till the expiration date of the cookies like expired.
All right, that was a really good explanation, Bikramjit. Thank you. So I'll save these notes for you. Okay, so sessions are server-based, cookies are client-based. Okay? When we store something in a session object on the server, our end user can't change it. That variable is stored in memory on the web server. The cookies are visible in our browser, right? We can just go into our temporary files and we can see our cookies. Now, those cookies can be encrypted, so we can't necessarily read the values, but we can easily delete them. We just go into our internet history and delete. We can choose to delete all our cookies if we want. And they can typically be set. Typically, when we use cookies for logins, what kind of expiry do you think most websites put in as an expiry date? How long do login cookies last on most websites? And well, how do we know whether, on some sites we can actually tell if they're using sessions or cookies? How could we tell? Yeah, you're okay. You're right. You're right. There is permission for cookies. So yeah, so that's true. I'll add that. How can we also know? Sometimes we can tell even when they don't ask for permission. They ask permission in a bit of an indirect way. Let's go here and let's have a look. Right? Facebook actually uses both. Well, how are these here? Right? If you go to facebook.com, you don't see these. So what's right? This is a cookie, right? It's in my browser. Let's see if I go to a private window. Right? So in my regular Firefox, I've logged in, so Facebook has written cookies as to those identities. Right? Whereas here, it doesn't see it. It has no idea what my history is. Which one of these is more secure? Yeah, this one, without using cookies, right? Which one is more convenient for the user? This one without cookies, or this one with cookies? Which is more convenient? Right, okay. So that's always the trade-off. Cookies will be more convenient because typically cookie can persist. The typical time for a login cookie is usually 1 year. So if you log into Facebook, for example, and you don't log out, you'll stay logged in that browser for a year. So anytime you come back to that browser, so you may think, well, this is great. I don't have to enter my username and password every time. You're right. That also means anybody that gets your device They don't have to log in with your username and password. So cookies increase convenience, but they're less secure because they're basically storing those logins persistently. So my advice to you as users is never choose keep me logged in, right? When you're asking for permission, that's what I was thinking of. There's sites with a login where there's a checkbox that says stay logged into this site. What that does is sets a cookie, usually for a year, that will keep you logged in. So yes, it's more convenient, but it's way less safe. Right? So I would recommend, even if you go to Facebook every day or LinkedIn or Reddit or Twitter, I log out of every one of those every day. When I'm done using them, I'm out. I don't stay logged in. And I don't recommend you do either. So which one of these methods do you think we should use for our, there's no right and no wrong, we can use either one. Which one do you think we should use for our vary each set? Should we store user identities in sessions or in cookies? I think I would always opt for security over convenience. If we have time, yes. I'm not sure that we will. If we don't, then maybe what I will suggest is if anybody wants to tackle it between this week's class and next week's class for bonus marks and give a demo at next week's class, this is how we could do it with cookies, then we could do that. Maybe as I imagine the things we want to do in order to get all this working, it's probably going to take all class. I'm actually glad we didn't have a quiz today. So good suggestion. So remind me if we don't get to it with cookies that we can do it. Okay. So I'll just save these notes so they're here. Okay. So generally sessions are safer. Some sites will use both. Okay. So we want to follow this workflow, and when a user logs in successfully, we're going to store who they are in a session object. So the session, it's readable and writable, right? So we can put values in the session, and then we can read those values out. So we're going to store their identity when they log in, and then on the top of every page, we're going to check the session object to see, do we have a user ID, yes or no? If we have a user ID, they're logged in. And if we have no user ID, they haven't logged in or their logout has expired. Actually, that's one other thing I should add on here. Anybody have an idea how long the default session timeouts are? So if we put something in the session. Now the session object gets refreshed on every new request. So as long as the user refreshes their page or goes to a new page, every time those session variables, they stay current. But if we load a page where we're logged in with the session and we don't do anything, we just sit on that page, how long on most web servers, how long will it take until the session times out? Yeah, that's the default, typically. So default timeout, typically 20 minutes on most web servers. We can override this because we might have a page that a user will interact with that one page for a long time. And actually show you what this looks like, because I once accidentally made a client very angry because I didn't realize this. I'll see if the site is still online. If it is, I'll show you if I'm oh, good. And hopefully I still have the login. Okay, great. So I built this form and I didn't realize, look how long this one form is. So here's the top section. And a user might be filling out all of this information. And especially this part at the bottom, calculating all the funds. So when we built this form, we published the website, and the users started sending me angry emails, and they'd say, I just spent 3 hours creating a new record, and then I finally got to the bottom and clicked save. So what happened once their session had timed out after 20 minutes? What page did they go to? Back to the login. So users were spending hours because they made the request to load the form, but until they submit the form, it's only 20 minutes and the session timed out. So what we had to do, first of all, was we put a timer up here. And when it gets down from 1 minute, it gives them a pop-up saying your session's going to expire. Do you want to continue? We also had to put save buttons in every section, because each time they hit save, it refreshes their session. So that's one way of doing it, or we can, in code, extend the session timeout from the default of 20 minutes. So if you don't change it, your forms will time out after 20, your pages will time out after 20 minutes. So sometimes we need to talk to our customers and find out if we're building them a really long form. We might say, how long is it going to take you from the time you open this page to the time you finish and click submit? Because we may have to make some adjustments so that you don't do all this work entering data and then you lose all your data and go back to login screen. So this will time me out eventually. It'll pop up an alert. I'll just leave it open and you can see. There really isn't a maximum. You can set it for whatever you like. In fact, I just did one where I sent it for 10 hours because I built an application and the customer, it's 3 screens that just selects data and they want them rotating like a slideshow in their office on a big screen. But they want to load the website each day when they come into work, and they want the site to run all day long. And for like a 10 or 12, so I set the timeout for 12 hours. So when someone logs in and brings up the first screen of data, it will just run all day and it won't time out and they don't have to log back in. So you can extend it. So there's always a balance again of it's balancing convenience and security, right? We don't want to leave it open for too long if it requires security at the same time. Okay. All right, so we're going to start. So the first thing we're going to need is right here. I hate sitting down, but for some reason the desk is broken. I can't raise it, so I've got to sit today. The first thing we need is a table in our database to store the users. We can't do any of this if we have no place to store user accounts. So we're going to need to log into our database in MySQL Workbench, and I've given you a quick script here that will build a user table with 3 columns: an auto-generated ID, a username, and password field. Okay. So let's log in to our database. I'll just run my use command to get connected. And on Blackboard, I think it's the 4th item here, it says user table script. And there's a pretty simple create table command. Creates a table called users with 3 columns: user ID, username, password. So just copy that, paste it in here, and execute the script. This will build an empty users table. If I look in the table now, I should have an empty. So I now have a table with no records, 3 columns: user ID, username, password. So just go ahead and copy that script and execute it. Now, notice the password field. Notice the size of the password field. Is anybody going to enter a 255 character password? Probably not. Why did I make the field so large? Wouldn't 10 characters have been enough? See? Why? Yep. Okay, right? So if I enter, let's say I enter this login. Here's my username. Here's my password. Test. You don't want to store the plain text value of our password as the word text. Why not? Why do we want to? We're not going to encrypt it, but we're going to do something similar to encryption. Right? What should the password look like? Instead of showing the characters TEST, it should look like what? And what would the value look like, for example? So we want it to be like, so we want it to be some seemingly random string of numbers and characters. We'll still enter the password test, but in the database, if somebody accessed our database, we want them to see that value instead. How come? Why do we want to convert this value to something that will look like this? Right, so that passwords are hidden or obscured. That's why on any site now, if you forget your password, what do you have to do? What happens when you forget a password on a website? Right. They never send you the original password anymore, right? They make you reset it. So, Jill, you mentioned that we're going to hash the password. So hashing and encryption are very similar, right? They'll each take a plain text readable value and convert it into something that looks like a random string. There's one important difference, though, between hashing and encrypting. And we want to use hashing instead. What's the difference between hashing and encrypting? Well, why do you have to? I'll give you a hint. Passwords are always hashed, not encrypted. This is why you have to reset it if you forget it. If the password on a site was encrypted, right, encryption is two-way. Encryption means we can take this value and convert it to this value, but we can also take this value and put it back. So that way you could say, I forget my password, here's my email, send me my original password. If we encrypted it, we can decrypt it, right? So it's two-way. So that would work for passwords, but hashing is one way only. Once we take this value and hash it and we get something like this, there is no way for us to ever see the original value again. That's why most sites make you reset your password because they've been hashed. There's no way to ever show you the original value again. So we could encrypt, but hashing is actually safer. And that's why we have to reset rather than decrypt and just showing someone the password. So this is why we're going to hash. We want 255 characters. Our passwords may not be quite that long, but they're going to be longer than 8 or 10 characters. And they're going to be random. Okay? And PHP has a built-in method called password hash. Right? Take a password and it'll do the conversion for us. So we're going to implement that in our site a bit later. So that's why our password value is longer than it seems like it needs to be. Okay. So there's our table. So our next step is register and login. Okay, so we've done this. The register page, we're not going to waste class time building a simple registration form with an email box and 2 confirm password boxes. We already know how to build, everyone knows how to build a form. So let's just download the register form. Okay. So if we open up the register form, here's all the code. So just copy that code. If we have time later, we'll add a little jQuery script that will make sure the two passwords match and can also check maybe for a strong password so the user doesn't put in a password of A or test. But for now, we'll just use it as it is. If we have time to implement those things, we will. So copy all that code. And let's open up our PHP project. And we'll paste it into a new file, which we call register.php. If you want to call yours signup.php, call it whatever you like. Doesn't really matter. I'm going to ignore this PHP Storm update for now because it's going to take some time to download an update, which I don't want. So I'm just going to make a new PHP file called register. And I'll take out the HTML that PHP Storm wrote, and I'll just paste in everything from Blackboard. So we'll just check it here to make sure it looks okay. We may have to make a few small adjustments. That's probably good as it is, really. So I've put a little placeholder in so that people know we want an email address, right? If I put in, it'll tell me it's not a valid format. I also added, if we look at the code, one thing I've added is I've added a pattern here. And the pattern says we need at least 8 characters with at least a lowercase, at least an uppercase, and at least 1 digit. So I've put that pattern in both the password and confirm boxes. So if I just put in the password of, say, test, it'll kind of tell me here my format's wrong. So we don't need to make any other changes on this form. As I said, we might later on add some code just to make sure these are the same, but we can always do that on our save page. We won't save the user unless they've given us 2 separate, the same password twice. So the other thing to notice on my form is this action goes to a page called Save Registration. So we're going to need to build this page. So on our save page, we're going to want to check that the password and the confirmed password match. We're going to hash the password, and then we're going to insert the user into our new users table. So we're going to need to build that page. Okay, this is actually a neat thing that PHP Storm does. You may have seen this if you're using IntelliJ in your Java course. So notice it's saying, okay, we're posting to save registration, and it's yellow, saying this file doesn't exist. So if I highlight this little warning, if I hit Alt and Enter together, it gives me a prompt. Hey, do you want to create a file with this name? So I'll just click on this and say, yes, as a matter of fact, I do. And I will add my file to Git. So now we have our save page. So if we click our registration form, we've now got the page. I'll put on the title here. This will mostly be a hidden page. If the user sign up is successful, we'll just save them and then we can take them to the restaurants page. We don't really need to show them anything here. So let's map out the steps. What are we going to do on this page? So the users put in an email address and they've put in a password and a confirm. So what are all, we won't write any code yet. Let's write the steps. What are the things we need to do on here before we save a new user? So this is the page that will load. Right, okay, so what should we do even before we validate the inputs? What do we usually do on the page? Yeah, let's take the form inputs and store them in variables. So we'll create a username, password, and confirm variable that are mapped to the 3 input fields on our phone. Okay, we'll validate the inputs. Yep. If the inputs are all valid, what should we do next? All right, in stereo, I like that. Connect to the database. Yep. Gosh. What should we do after we connect to the database? Okay. We will execute. Yep. So we'll maybe set up and execute. Insert. Yep. What else should we do? Yep. Disconnect. Where should we take the user after they've signed up? Okay, we could, yeah, maybe redirect them, get them to log in, potentially. We might take that out later, but we could ask them to go and log in. Now, there's one step missing. All of this is good. We will need to do all of this. And most of this are things we already know how to do. There's really nothing new here. There's actually only one new thing. Otherwise, it's just like any other form that we save to the database. What's the one thing that's special that we need to do in this case besides just saving the inputs to the database? Rish? Right. Before we save them, we need to hash the password. Right? Because remember, if we don't hash the password in the database will look like this. Instead, we want it to look like this. So once we know the inputs are valid, we should hash that password. So we'll just add a step. So this part is, then this will just be one line of code. So there's actually only one new thing on this whole page. Everything else is stuff we've already been doing. So we'll create 3 variables. I'll have a username. We look at our form controls. Right, we've got username, password, and confirm. So we'll create 3 variables with those same 3 names. We want to make sure none of them are empty, that password and confirm match. And we should also check at least that the password is 8 characters. We won't check the whole regular expression, but we'll make sure on the server end as well, the password is at least as the right length. So we'll maybe use our favorite OK variable, just like we've done in the past. We'll set it to true, and if we encounter any validation errors, we'll change the value to false. We'll make sure username is not empty. We don't really need to check password and confirm for empty. We'll actually check the length of those. If they're empty, obviously the length will be less than 8. So we only need one check. So we can use a string function in PHP that will tell us the value, how long is that string, and if it's less than 8 characters. Think of the right function we want. There is a string length function. It is escaping me. I'll just do a quick search for it. strlen. So if our length password is less than 8. We haven't used this function before, but it's fairly simple. Tell us how many characters are in any string. So now we need one more check. What will our other if statement be? If something. What's the other condition we need to check for? That our username's not empty, that our password is not less than 8 characters.
He restricted the website or not?
Sorry?
Is the user restricted with the website or not?
Ah, okay, that would be that's another so yeah, what if it's an email address that we already have in the database? Okay, so that's going to be something we'll have to check separately, right? Because we've got to query the database in order to check that. So we'll come back to that one, Bikramjit. Just thinking about the inputs, right? Here's our form, username, password, and confirm. So we've checked that this isn't empty. We've checked that this isn't less than 8. What's the other check we need here? We'll leave that one. That one's a bit more complicated. We'll leave that one out for now. What about this? This input here, what should we be checking? Right, we want to compare that confirm and password, that these two values are the same. If password, here's our not equals in PHP. I believe it's the same as in Java. If these two aren't equal, what should our message say? Right. The passwords didn't match. If we have time to check the duplicate email later, we will. Okay. So there's our validation. A username is empty, password is at least 8 characters, and confirm and password are the same value. Any one of these things are false, our validation should fail. Okay. We can maybe do a quick check of these things. At least if I do test that. If I put in 2 different passwords, I should get the message that the passwords don't match. If I put in no errors if I put in the same password twice. Okay, so far validation's correct. Now, once we get this working, I'm going to want everybody to create an account. But I've learned through experience, we all need to create the same account. Here's why. Because you'll create the account today, and from now on, when our lesson's done, everything on your site is going to be private. So you won't be able to change anything unless you have an account. And if you create a login today and you forget next week, you then have to go make another account because you've locked yourself out of the website and your password's hashed. You can't look in the database what my password was. So I'm going to give everybody the same username and password and say, we're all going to sign up with the same account in our own database, okay? So that we don't forget and lock ourselves out of our own website. Okay. So now we need to hash the password. So if OK is true, if OK is true, we're going to do all this other stuff. So I'm just going to move all of these things inside of an if statement, making sure that our data, our inputs are good. I'll create a new variable called hashed password. Should be fairly self-explanatory. Hash password, we're going to set it equal to, here's our method. So this is built into the PHP library. There's a method called password hash. Now there's different versions of this algorithm. So we can hash kind of to different levels. We'll just use the basic one and we'll see how long that resulting string is. It'll be less than 255, but it will certainly be longer than 8 characters. Oh, wait, sorry. It's telling us we're missing a required parameter. We'll go back and check our password hash method. Look in the documentation. We'll use just the password default. So it says this, they've recommended 255 characters is what you set up in your database. So we'll use password default. So there's some different hashing algorithms. We'll just use the default one. Now everything else is just as normal. Connect to the database, set up and run the insert statement, disconnect, and take the user to log in. We'll disconnect that at the bottom. I won't put in the code to redirect yet, because if we get an error and then our page redirects, we'll never see the error. We'll make sure this is working first, and then we'll put in the redirection at the end. We're going to insert into users. You don't need the confirm value anymore. The confirm is just checking at the top that the user put in the same password twice. We don't actually need to save 2 versions of the password to the database. So there's our SQL command. We're going to save the username and the password. The user ID is auto-generated in the database. We'll prepare our command, and then we'll fill up the parameter, the username and password parameters. Our username is 50 characters. Well, our password parameter, what value are we providing to the password parameter? We've actually got 3 different variables that hold the password, right? We've got password, we've got confirm, and we've got hash password. Which one of these values do we want to actually put into the database? Right, we want the hashed password to go in here. We're setting 255 characters for that one. Then we can execute the query, which will save the user to the users table with the hash password, not the plain password. Now you may be thinking, well, if we hash the password and we can't unhash it, how are they going to log in? Right, so we'll come back to that. There is a way to do it. We'll come back to that later. So let's try this. So here's the login. I'm going to write it on the board, and we're all going to use the same login. Okay. So that next week when somebody says, I don't remember how to log in, everyone else in the class can just shout out the login to you. We'll keep it really simple. So here's your username, test@test.com. And we need an 8-character password that has at least one number, at least one lowercase, and at least one uppercase. So here's the password. Capital T, test, 1, 2, 3, 4. Okay. So let's everybody fill out your register form using those credentials, and then we can look in our database and see if the user got set up. So I'll put in test@test.com as my username, this password. If I register, hopefully we can then look in our database and we should have a user account. And then we can also see how that password hash works. If I enter this 8-character password, what does that value actually look like in the database? So register. Didn't get an error, so that's good. So now if I run a select star from users query, so here's my username and here's my password. We can actually see how many characters this is. So it's exactly 60 characters. Now there's one other thing we should check out of curiosity. What will happen if I create another account, pick a different username, put in the same password? Is it going to hash it to this exact value, or is the hashing unique? That even if 2 users put in the same password, the hashing will store it separately. I'll try it in mine and we can see. You don't have to necessarily try it in yours. So I'll go back. I'll put in the exact same password, test1234. And then I'll run this query again. So how does that password hash work? Did we get the same value or different? Right. Is this a good thing or not a good thing? It's good. right? So even if we have 100 people that all use the same password, the PHP password hash algorithm will store each one of them uniquely. So I don't know exactly how it works. It may take either it just generates some kind of random string in using the hashing. It might take the current date and time. It might take the user session ID. It generates it using some kind of unique value. So this is good, right? This is more secure. In some of the older versions of this, if two people entered the same password, they'd actually be hashed the same way. So this password hash is probably safe. So could we have used 60 characters in our table? We could have. We didn't need 255 characters, but the PHP documentation recommends 255. The reason is, in future versions of PHP, they might update this password default version. So today it will generate 60 characters. But if PHP, if they update that library in future versions, they might decide we want it to be 80 or 100 or 200. Well, now we don't have to go back and change our table. Our table's big enough to allow that to grow if they change this algorithm later. So 255 is, we're following the official documentations, kind of their recommendations here. So now we can sign users up. Well, we can worry about redirecting later. Right now, we don't even have a login page, so there's no point redirecting them because that file doesn't exist yet. So we've done this, we can sign users up. Like I said, if we have time to come back later, there is a neat little JavaScript we can use that would actually write on this page as the user types, indicate whether their password is strong, right? It would show them red, yellow, or green, how strong the password is. So there's a neat little code library. I have it. If we have time to implement it, we will. But if not, at least this is functional. And I can show you where that library is. You could try and work with it on your own if you want. Does anybody have any questions about our register page and our hashing before we take a break? Yep. Yes. No, it doesn't require a special character. It requires, so this indicates the D means a digit. So there has to be at least one number, 0 through 9. Yeah, there's the lowercase, there's the uppercase, and that's the length, minimum length. So I didn't actually require a special character for this. Good question. Okay, so what we're going to do, I'm going to pause the video stream. I will push what we've done so far up to GitHub for you. Let's take 20 minutes here. We'll come back at 12:35. We'll work on login, which again, you can just download from Blackboard, but we'll have to build the page that checks the logins. And once we can successfully validate a user's credential, we'll need to do this. Store their ID in a session and check on all the pages if the user's logged in or not. And also give the ability to log out, and then we'll look at some of the other things, like can we use a cookie? Can we show the strength of the password? We'll do as much as we can today. Okay, so we'll take a break.